Yeah.
Cool.
Okay, it should be. Okay, it's recording.
Yay. I think.
Okay. If you if you go downstairs, you know that chair that the baby's on? Blue folder.
Okay.
And my textbook's right there too if you want it. So are we thinking midterm practice or are we thinking like corrections?
I'm feeling corrections. Although, I mean, I guess I'll do whatever. Although,
Okay. What do you need to correct then?
I need to do motion FRQ.
I did that one. I've got that one. I went to the help session. I've got
Oh, that's great. Because I didn't. I still don't know why I'm wrong. Which was weird because I felt good about this one. I was like, yes. After we done, I was like, I think I did okay. I got my score. It's a 1 out of 9.
I feel that. Okay, so motion. I turned in all my corrections, but I took pictures of everything, so give me just a second. There's my motion. All right, so which ones did you get wrong?
All of them.
All of them.
One
You still
point.
did better than me.
I got 1 point on the first on 1A.
Okay. So, what did you try to do?
I
guess
tried like the EVT thing, where I figured the first leftmost points it's going to be either the start point, end point, or at a point where the derivative is equal to 0.
Okay, so you did. That's good. So, what points did you get?
0, 3, and 5 were the ones I tested.
So 0, 3, and 5 are all correct. Your other endpoint is 6.
Oh.
So we know that because you want to find position, right? And we know velocity is the derivative of position. So did you go and find position at all, like the position interval?
No, I do not believe I did.
Okay. So when we were going over it in the health session, that one. The first thing that we decided was to see if the x of t, which is our position graph, is continuous. And we ultimately decided that yes, it is continuous on the interval 0, 6. And then you basically do what you did was find the thingies, the critical numbers. Yeah, the absolute extrema.
Mm-hmm.
Okay, so we know that position at 0 is -2. It gives us that in the problem. And then how did you try to find x of 3 or position at 3?
I did the integral from 0 to 6 of v of t. Not sure why I did those numbers, but I'm sure I had a reason for it.
And what value did you get?
I got -5.
So when at the help session, we said x of t is equal to -2 plus the integral from 0 to 3 of v of t d of t. And so we found, remember the problem where it was giving you the area on the certain intervals?
No, but okay.
So hold on, let me pull it up. So yeah, so it says the velocity at these places has, no, that's not the right word. Okay, the graph of v on the intervals 0, 3, 3, 5, and 5, 6 are 8, 3, and 2 respectively. So they gave you the area under the graph to the x-axis and the problem.
Yes.
So what we did was we basically, from 0 to 3, we know that that is -8, right? And so then we did -2 minus 8 to get that full area. Does that make sense?
So on you -2, where did -2 come from? Is that the
So we
from
know
4 to
that
6?
in the problem it gave us the at 0 it is -2.
Oh, yes, I see that now.
Mm-hmm. And so then we do -2 minus 8, and that gave us -10. And so you kind of do the same thing for all of your numbers. And
Yeah.
then so either you can on the next one at x of 5, x position at 5, you can either do -10 and do 0 to 5, or you can do -2 and do the integral from 0 to 5, or you can just take that -10 and do the integral from 3 to 5. You know?
I
Does that make
believe so.
sense?
Yeah, you can just, yeah. So
Yeah.
that one would be -7.
Look. Yes. And then for the next one, you just do the same thing.
Awesome. Let's write some of this down.
Did you find it? Okay. Which ones did you still need?
So I found 34 and then 31, 52. So I spent that 4.4 practice, 28, and then the 35 and 37 for 40. Which
I have not
is-
done those 5 yet.
Yeah,
I need to
I've
print
done
those off.
all of that one except for the graph one.
Gotcha.
So I can give you that one, but I haven't done the graph. For
Okay.
it, so.
As long as you found what you needed. Did you get position at 6 yet? Or are you working on that right now?
I'm still writing down what we just went over. So
Okay.
but when we're solving, so that's just going to be x of 0 equals etc. X of 3 equals whatever. That's the
Mhm.
okay.
Yeah, so the way I wrote it down, I just put x of 0 and then equal signs -2, and then x parentheses 3 equals -2 plus the integral 0 to 3 of v of t d of t equals -2 minus 8 equals -10. Does that make sense?
Yeah.
It's just the way she said was just show your thought process for all of it.
Mm-hmm.
And show
Okay.
like even if you're not for this one specifically, but even if you plug into a calculator, just put it all in and show it on the paper.
Gotcha.
Is that how you spell monuments?
I have no idea.
Sarah, how do you spell monuments?
Okay.
Monuments. Yeah.
Yay! All right. Why is your nose bleeding?
I don't know, people.
That's a great idea to figure out why my nose is bleeding.
No, I meant Google how to spell monuments, but.
Or just ask Lexa.
Alexa, how do you spell monuments?
Monuments is spelled Monuments.
Hey, I spelled it right. Guess you can spell.
Not me.
Gail, you can't spell.
Yeah, I know.
Why am I on TripAdvisor?
Oh, it's because you probably looked something up that pertains to TripAdvisor.
Ow, my nose.
That's what you get for making it bleed.
My nose.
Miss Vic's gonna be watching this and she's gonna be like,
What?
what's going on?
So for the final answer,
Mm-hmm.
so the particle has its leftmost point of
Mhm.
-10 at t equals 3.
Yep. And what did you end up getting for x of 6?
-9.
Yep, you're good.
Aha!
You done did it.
I did
Okay.
I did the thing right.
So let me look at B, because B was when the position is at x equals -8, right?
Let me scroll up. For how many values of t is the particle at x equals -8? Yes, explain your reasoning.
Okay. So this one I was a little bit more iffy about in terms of like true explanation, but I can walk you through it as best as possible. So once again, we need to state that x of t is continuous on the interval. So that's what we did first. And then she said that, we already did the work in part A that we would need for part 2 or for part B. So we just need to know when position is at -8. So we know that we're looking at the area where the velocity is negative, right? Right? I don't know. I'm trying to do stuff. So we just stated that at we have a point that's already less than -8, right? For x.
Yeah.
We have x of 3 is -10. So we stated that that is less than -8, which is less than basically all the points that we have found, all of those critical numbers.
It's going to be a point where it's -8. Oh, okay. Gotcha.
Yeah.
Okay.
So whenever, like for the first one that we wrote for x of 0, it was x of 3 equals -10, which is less than -8, which is less than x of 0, which equals -2. So we're basically just showing that it's in between those two numbers. And we know there's at least 1 point.
I mean, between 0 to t to 6, we can say there are 3, right?
Mm-hmm.
Because we can look at what we have, and we know it's going to be rate of change is going to. I don't know. I know what I have to say in my head. I'll figure it out.
Yeah. You get the gist of it. That's the important part right now. And then so that was just all the work we showed was basically just that negative x of 3 equals -10, which is less than -8, which is less than x of all the points, which equals whatever that number equals.
Yeah, that makes sense.
Mm-hmm. And then just make sure you state at the bottom that for that the particle is at that position for 3 points on the interval. Solid sound.
I almost made an explanation that would not have been recording Zoom being friendly when I heard that noise. I remembered we were recording and I was like,
wait.
You know you're gonna probably have to edit that.
Nope, I'm gonna send it unedited.
Miss Pig is gonna be like, what in the world is wrong with
Well,
these
too
people?
bad. Sorry, Miss Pig, for whenever you are watching this. I did not mean it in an offensive way. I just meant that it is going to be a good length video, and I don't feel like editing out everything.
Because editing is a pain.
You're lazy. Turns out students are real people.
So let's see if the camera picks you up.
No, don't pick me up.
Yep, there she
My
is.
shame. Ha ha ha.
Hide the hat.
Well, you
Oh,
saw
yeah.
her for a second.
I was gonna
And
say.
then you have over here my sister. Yeah, Miss Pig is a party.
They are the background.
Just breaking the fourth wall.
What is this point? -7. And this
I don't know her.
-9.
How do you spell beautiful?
BEAUTIFUL. Beautiful.
How old is she?
My sister?
Yes.
I'm 14.
14.
Not young enough for it to be legitimate for you to ask us how to spell words.
Well, the thing
Unless
is,
they are like really, really hard words, like scrumptious.
or
Okay, but she has to have a
supercalifragilisticexpialidocious.
monument and beautiful.
Okay, well the thing is,
Okay,
I'm
okay.
used to spelling in French for this stuff, but I have to do it in English. I'm not good at English.
Dude, Google it. I'm shaking.
I don't do well in English.
Okay, do your homework so that way Miss Pig doesn't have to listen to you scream and yell.
Alrighty.
Okay. I have no idea where those pencils came from.
So for C, is not the speed
What?
the speed is decreasing, right?
Yes. But the question is, do you know why?
Yes,
Why?
because the derivative of the velocity graph between 2 to 3 is positive.
The derivative of the
Okay.
velocity graph, you said?
Yes.
So the acceleration graph. Because the derivative of velocity is acceleration. Okay.
Acceleration is positive between 0 to
Mhm.
3. However, the speed prior to that point, or well, the velocity prior to that point, excuse me, is less than 0. So because we have different signs, it is decreasing.
Yes. You're exactly right, actually. So the way we actually worded it out is speed is decreasing because B of t and A of t being acceleration,
Yep.
have opposite signs. I wrote signs twice. On the interval 2 to 3, V of t is less than 0, and A of t is greater than 0 because V of t is increasing.
I got the right answer. I just didn't write the right reason.
I did the same thing.
Although, to be fair, 50-50.
Why, Kayla?
It's not mine. It's legitimately not mine. I don't know why it's here.
I looked over there.
So fun fact, where we're at right now is still a crash site for my surprise birthday party. And Kristen just found a tub of icing just randomly here, and I don't know where it came from.
Here, show 'em.
Nice.
Dropped the remote.
Man, my face is very white from this lighting right now. I just looked at the camera like, wow, I look really white.
There's a reason I have a backdrop. I turned the camera on before you got here, and I was like, oh,
Show 'em your
no,
Does this make things
out
better?
of here.
No, I can't, because it's
Now I'm yellow. I
You're,
don't know if this is any better.
you look fine. You look fine. Your life is a photo shoot.
Miss Pig, we're sorry.
Speed is decreasing because that equals the acceleration at t, and a of t is positive the interval.
Somebody was eating out of this with a spoon.
Well, there's a spoon up
How do
there.
you eat out of it?
Huh?
Yeah, how else are you supposed to eat out of it?
With a fork like a civilized person?
Weird.
Or your finger?
Forks are superior?
You're out
Finger.
of forks.
That's how you spread germs.
With a fork?
Yeah, I was on the interval.
Oh, wait, that's mine.
2 to 3, 2 to t to 3,
Is this bringing back memories?
and
What?
Is this bringing back memories? Doing calculus?
Calculus, my childhood, man, it's all there.
the absolute value of velocity.
Also,
Gil.
Nope,
I have
wrong. That's wrong.
Can I
Back up.
run with him?
No. Or do. I mean, I'm not your family.
You're also not Kayla.
I thought that was a given. Am I not?
I said Kayla, not Sierra. Try saying that 10 times fast. Yes,
Hey,
yes.
stop eating out of the icing. That's actually not good for you. You're gonna give yourself a heart attack.
I'm 14, Caleb.
It doesn't matter.
Dude,
Legit,
it
stop.
doesn't matter.
Stop eating out of the icing with your fingers.
Would you rather me go get the spoon?
No, I'd rather you not eat it at all. It shouldn't even be up here.
I don't remember bringing it up here, but I do remember it's mine.
Okay, that's done.
Okay. So the last question is, when is acceleration decreasing, right? Or negative, sorry.
Yeah.
When is acceleration negative?
Well, you're pretty close. They mean similar things ish.
Similar, but not the same.
Yeah, not quite. No.
So where do you
acceleration.
think acceleration is negative?
Let me think. I would say from 0 to 1 and from 4 to 6.
Then you would be correct.
Well, that's just like looking at the derivative.
Yes and no. So the justification is because the velocity is decreasing.
Okay. I mean, velocity is decreasing because the derivative of velocity at these points is negative. Is that just how she wants us to justify it?
That's what we wrote. So the acceleration is negative when the velocity is decreasing. So I can think about it from a physics standpoint and very much understand it.
Mm-hmm.
So, because if I don't know how to explain this without it being like really, really confusing.
It's
Let me
fine.
look at a visual.
The reason I got that one wrong is I just didn't have enough time. I just didn't answer it.
That's understandable.
What's the question?
During the interval, during what intervals, if any, is this acceleration of the particle negative?
So acceleration is negative when the second derivative of position is negative, so it's also going to be concave down.
That's what it is. It's when it's
Uh,
concave down.
It's concave down and velocity is decreasing.
Yeah, but that's what I can think. That's, yeah. Josh knows. Don't you, Josh?
Yep.
Me vaguely remembering calculus.
I can think about it as from a physics standpoint, from like the calculus standpoint, it's a little bit harder because the words are wonky. Well, they're
Yeah,
not
I took-
wonky,
I
but
took only one physics while I was taking calculus, and now I'm taking both physics C. So I feel you. I'm physics, but
Okay, cool. Thank you. Gracias.
then that does.
So what do you need to do?
So fun fact, when I was in the help session yesterday,
Mhm.
I did all of my corrections for all of my FRQs. So all I have to do is retake all of them.
Nice.
Yay. And I was also like eavesdropping while you guys were talking about rates, the rates FRQ.
Mhm.
So I got a lot of what you got.
Nice. Yeah. When you were talking, I was like, "Huh, that voice sounds familiar." Because I was still on the call because I was gonna ask her something. I was like, "I know that voice. Whose voice is that?" And then she like name drops. I'm like, "Oh, should I say hi? No. Yes, it'd be funny." But I don't want to interrupt them. I ended up not.
No, I legitimately you guys were talking about like B through C, B
Yeah.
through whatever the last one was,
Mhm.
and I was sitting there. I was like, uh-huh.
Uh-huh.
Oh,
Tell me about
I get it. I get it now. No, you stop it.
I was so mad
And
about
then-
that one because like I messed up in part B, and then I used
did
that
not
to
mess up in part B.
answer every other question.
I got both of the points for part B, and I was so excited. But for part A, I was a big dummy because I didn't plug the right thing into the calculator. So there was that. I felt kind of dumb. And then for part C, I went about it in a way that made sense in my head, but was like completely like off the rails. Like, what did I do? Oh yeah, I did R of T and D of T. Or yeah, I did those and I did them both at 0 and both at 8 and then expected them to like mysteriously like work in my head. And then I
If I
ran out
just
of time.
put them together, I'll get the right answer somehow, right?
That was what my head was like.
Yeah.
And
yeah.
then when y'all were doing it, I was like, so in B part, I sort of did what she did with the A of T,
Mhm.
sort of, but I
Yeah.
didn't like put a name to it and I didn't do it in the way she did it.
Yeah.
So like with the C part, I had to go back and think about I did basically this, I did what she did
Mhm.
on my corrections, but I actually like put in names like what I was doing. I created a whole nother like integral.
Yeah.
And then like everything just clicked and it made sense and I was so happy about that. And then I just didn't even do D part. I ran out of time. I was confused.
Yeah, it's like in B, you know how we had to define the equation for amount of water in the
Mhm.
pipe? I misdefined that. Like B and C,
Huh.
no, D, I did the math right, but I was just, my equation was wrong.
So what I did
It was annoying.
was I didn't do A of T. I just found R of T and D of T and then subtracted them.
Mhm.
Does that make sense?
Yeah.
That's what I did. So I did A of T, but I didn't say I am doing A of T.
Gotcha.
But she was like 2 out of 2, and I was like, yes, I
Score.
will take it. So, I mean, all I have to work on for her right now is retakes, which I can't do here, and then this handy dandy packet that's like this thick.
Mhm. Okay. So obviously I don't have her in class, so I have to print it out, right?
Yeah.
So I'm not sure what it is, but like, I guess the text is like finer than a normal text editor.
Mm-hmm.
So what happens is for every single page, it comes up like this. Now, I'm not sure if you'll even be able to read this, but do you see
I don't like that.
everything is like only half there. It's like if you did it and then tried to erase it. So
Do you
like
need
the last packet she made us do, the what's it called? The integration packet. I couldn't read what I had printed out. I just printed it out, looked at what I had printed on the computer, and did my work on that. But I wasn't actually getting the answers from, or the questions from the packet because I can't read it.
Do you
And this
need
happens every time she has us print something.
do you I was gonna say, do you need me to like scan what I have and like send it to you?
No, I can pull it up on the computer. I
Okay.
just need to find wherever she put it.
It's under content library under midterm review.
Midterm review, lovely. Okay,
And
did you
then
print the
it's
AD one
two
or
of
did you
them.
print the BC one?
Both of them. You need both. Because the
Yeah,
first
well,
part
which
is
one are we doing
AB.
right now?
I was just gonna work in order and go AB first. I mean, I have probably upwards of 20 pages.
I'm not sure which one I have because I printed the first 3 pages and then I was like, you know what? I'll just write the questions down on a piece of paper because when I scan these and send them back to her, she can't read the stuff. So it's like, what's the point of even printing it in the first place?
Oh, speaking of the integration review,
Yeah.
so I turned it in and she was like, you gotta fix some things. I was like, okay, so I just got some stuff wrong.
Mm-hmm.
And I was flipping through it and so first of all, I did not do 19 and 20. I don't know why. I did not finish 22. That was a rates. Which one was that? That was a rates one. So I can always I'll fix that probably later. But I just apparently decided not to show work on some of them. So that's great. I'm gonna have to do that tomorrow. It's all right. Mr. Walker's not here, so I'll just do it in his class. Miss Piggy didn't hear that. I promise. Anyway,
Your secret.
huh?
You'll keep your secret.
Miss Pig knows what's up. Every time is calculus time.
I realize she's gonna watch this, right?
Yeah, I know she's gonna watch it, which is why every time it's calculus time.
Are you just doing that to
You're just like so what class?
like
What
you?
class do you have next? I have second calculus.
I've got.
And then third calculus.
Yeah.
Followed by fourth and fifth calculus.
Is there any other time to do calculus?
The best time to do calculus is in calculus class. Second best time is in economics class.
Second best time is any other class.
Any other class, you're right. I'm dumb.
Right.
But no, realistically speaking, I spend every single day with her at some point doing calculus. So every time is calculus time.
Speaking of Mr. Welcome to class, do you have, so this says due on a separate sheet of paper. Do you have that other sheet of paper?
Nope, because I didn't do it.
Nice.
I was doing calculus. Okay.
Regardless of
How are you doing?
you're doing calculus.
Huh?
Sarah, how are you doing in the background there? Yeah, you
I'm
just don't
in and out of
exist.
existence.
You just don't exist. I'll feel
Now
like,
I exist.
oh, look, there you are. Hi. For a brief period of time as half of your body just morphs out of existence.
And then I
Oh,
disappear.
there she
Oh,
It's
oh yeah, when Caleb
Sierra.
pops back in, I
say hi to
Phase
Miss
out.
Pig.
Hi, Miss Pig.
Oh,
You wanna-
Sarah, by the way, I cleaned your sippy cup, so it's downstairs on the counter.
Yeah. She's got her big kid drink right now, though.
I do.
It's not alcohol. It's not. It's just Starbucks.
It's just caffeine.
It's just
which is
caffeine.
basically alcohol.
No, we can't say that word. This is a school appropriate
Alcohol?
water video.
Alcohol?
Okay, let's just get back to the
We're gonna ignore
packet.
everything that just happened in the past. Like,
Okay.
Right,
yeah.
We call it
integration. Derivatives, fun.
Yeah, integrals.
Oh yeah. I love it when the area under the curve becomes large.
I mean, it could become small
Sierra.
depending on the graph.
True. It could converge. diverge.
It's candy.
Oh yeah, and then I love all those derivative rules, the product rule and the quotient rule and the
Oh
chain.
yeah.
Crazy.
You know my favorite rule?
That was actually surprising.
Stop throwing things. No, seriously, stop throwing things at me. I've got to do math.
That's
It's
my favorite.
calculus time.
Wait, there's three more.
No, stop throwing things at me.
Wait, you said AB first?
Okay, so what all have you actually done with the packet?
None of it.
Excellent. So we went over some of it today. So do you want to work on those problems that we went over, or do you want to like go over problems we didn't go over?
Why don't we do stuff we haven't done? Because I feel like I'm just dragging you back to where I am.
Okay. So
What problem are you on? And then I'll
problem
just-
number 3.
I broke my turkey.
Or not, well, the second problem 3. So if you go on the AB,
Oh, whoa, there's
I
two
can't fix your chair right now. It's calculus time.
It's Kristen's chair
Right.
time.
Stop.
There's two problem 3s. That's crazy.
It's the second problem 3.
I'll just like start here and then hopefully I have enough room above. Okay, if f of x equals that equation, then f prime equals
The other number 3.
the other number 3.
Yeah. So, oh shoot, there are 3 number 3s.
Yeah,
The
there's three.
third number 3.
Mhm.
My bad.
Gotcha. For x is greater than 0, the horizontal line, is that the number 3 we're looking at here?
Yes.
Cool,
Yeah.
cool. It's an asymptote for the graph of the function f. Which of the following statements must be true?
Okay, so
y equals what? Is that supposed to be a 2?
Yeah, y equals 2 is an asymptote for the graph. Okay, so if it's an asymptote and it's y equals that, so that means it's a horizontal asymptote, right?
Yeah.
Because we have the y value and not the x,
Yes.
which means at that point the tangent line would equal 0. Okay, so hey, I know this one because there are limits. Wait. I
all those
think
words separately, but when you put them in that order, that didn't make any sense.
okay. So I'm looking at the answers right now, and I am like 90% sure it's E.
Limit as x approaches infinity, f of x minus 2. What?
F
That's
of
what-
x equals 2.
This is not me reading from what's printed. This is me reading from the PDF.
You're doing great.
How am I supposed to do the problems when the
Hold on.
problem?
Hold on, I can pull it up and I can
assume Josh can read.
I'm gonna pull it up and see if I can screen share it with you and if that'll be better.
On what OneNote?
On Teams.
Oh, on Teams. Okay.
Yeah.
That's my cooking.
Oh wait. Haha. Bold of you to assume that I can't. That was a screech. Okay, so this is gonna be under content. Midterm review. Haha.
Oh.
Haha.
Oh.
Share screen. Haha. Can you see it?
I do see it.
Is that any better? Let's see if I can
It
zoom.
looks. Yeah, it still looks like a minus. See? It
Zoom.
still looks like limit as
It
x
will
approaches
zoom.
infinity of f of x minus 2.
Well, on the bright side, we can see the same thing now.
Yes. But I do agree with you. I do think the answer is E.
Zoom. Really?
Yeah.
So this one?
Yes.
Yeah. Okay. Wait. Stop that so I can scroll. Oh, crap. Why does it go with it? No. Wait. I can annotate, erase, whoosh. Mouse. Well, let me. It will. Holy crap. Okay. So we said E. Sorry. I'm playing.
E as in elephantitis.
There we go. Okay.
Did you say E as an elephantitis?
Actually,
Yeah.
he said E as an
Yes, no, I was
elephantitis.
directing my question at Josh.
Yes.
Just making sure I wasn't going more crazy than I already am.
Okay. So the next one I have is 4.
Yeah, 4.
Yeah. Okay. So we're trying to find the derivative. So if I'm so the derivative. Hold on. Sorry. So I know.
Chain rule.
Did you just say the interval?
I said chain rule.
Oh, I thought you said the interval. And I was like, interval. Okay. Yes, it would be because if I can I draw? No. Let me draw. Oh, let me. How do I draw?
You can do it. You can do it.
I can do it. Yeah. No.
I believe.
Haha.
You.
Because this one right here is the outside, and then this will be the inside. Look at that beautiful straight line. Holy biscuits. Anyway. So we know that the outside, so if we assume the inside is x because that's a unit, we know the derivative of the outside, ln of x is, the derivative of that is just 1 over x, right?
Yes.
So that's going to be 1 over secant of x times the inside. The derivative of secant of x is
I
it
did not.
tangent secant?
I don't have them memorized. I'm sorry.
I-
I would.
No, you're fine. Let me
Here,
just pull. I have my journals right in front of me. That's arctangent. Okay. Yes, it is secant tangent. So it's going to be
Really?
times secant of x, tangent of x.
So
Which
doesn't
is-
stuff cancel out tangent x?
Yes. Oh, I gotta continue doing this so I know my thought process.
Yes, right.
Now, if I scroll you now, are you gonna be a jerk?
You can do it. Maybe we'll see. I don't want to get my hopes
Nope.
up too early. What are you doing? Are you annotating with Zoom itself?
Yes. You can annotate too if you'd like. Just hover up. Can you see my mouse? You can see my mouse. If you hover up here and annotate.
Yeah. Oh wait, I can.
Yeah, you should be able to.
Whoa.
Go ahead, try to draw something.
Da-da, da-da.
Josh figured out how to work Zoom.
This time on.
Okay.
Yeah, that's what I was going for. Thanks.
She said, Josh figures out how to work Zoom, and I said, this time on. Look at you to go! I can see your scribble.
Mm-hmm. Now what's
Okay.
remembered?
So next up is 5.
When x approaches 0. That long equation.
Okay, so we know if we plug in 0, it's going to be 0 over 0. So it means we can use L'Hopital. But the first thing that I think we should do, to be honest, is go ahead and factor out those x squareds from both the numerator and the denominator. And that'll let us simplify it. Okay.
Oh yeah, that'll make things a lot easier. Who's calling me?
X squared.
Oh, that's an important call. Please hold on a moment.
No.
Uh-oh. Hello? Yeah. Yes.
Oh shoot, I didn't write limit.
Gotcha. No problem. Bye.
Bye, person.
That's my dad. He's coming home with some groceries. I'm gonna need to help him take them in. So in about
It's all right.
5
So-
minutes, I'm gonna
so
need to
af-
go, but then I'll be back.
So, well, I was saying we could finish it. Hold on. I'm gonna text you something real quick.
Okay.
Give me just a second. Take your phone real quick.
Okey-doke.
I'm gonna write down what I did real quick and see if I can make this look good. Okay. I don't have a pen. Actually, that's not gonna end. Well, what if I did
I
text?
gave my phone, but I don't think
Oh.
it's compatible.
I can just do it that way. This is so janky. No, look at it.
Bad.
Okay, Okay,
It's a-
but that's that's literally me the entirety of this year, right?
I just responded to your message.
Download
Huh?
PDFs.
I just responded to your message.
Yeah, I agree.
Yeah, sure. Let's do it.
Yeah, we can
Let's,
just
let's,
stop.
finish with this one before we go.
Yeah.
See if we can do that in time. Huh?
So, okay, I don't think this is gonna work very well, but you get the gist. Did you basically get the same-ish thing?
Yeah.
Okay.
And that way we only have to take the derivative of the 5x squared plus 8 and then 3x squared minus 16.
Okay. I'm just gonna.
Pretty sure I'm spelling this guy's name wrong.
There we go. Okay. So let's sit back down. Okay. So that's what we get, and then we can use L'Hopital.
You can do it.
L'Hopital. Okay. Hospital. That's
Yeah.
all I know. Okay.
Oh, L'Hopital.
I don't like that you know that. Okay, so then when
What? We
we
had to learn
stop. So then when we take out the x squareds, those two cancel out and we're left with the limit as x approaches 0 of 5x squared plus 8 divided by 3x squared minus 16.
Yeah.
And I've got to think about how to do him again.
You take the derivative of the top one of the numerator and the derivative of the denominator. You take them both separately, and then you put the derivative.
Oh, that's right, because it's same over same, large over small, that one, right?
That made no sense to me. I don't answer that question.
So then you get the limit as it approaches 0 at the top, right? Wait, do you have to take the derivative, or do you just take the limit of both?
I thought it was derivative. I can look it up real fast. Oh,
Shit.
The equals the limit of the derivative over, of the derivative of the numerator over the derivative of the denominator. Yeah.
The more you know. So we need to do the limit as x approaches 0 of 10x.
Or 6x.
Yeah, and then 6x.
Zero,
But the thing is, still, whenever you plug in the 0, you're still going to get 0 and 0.
yeah, so we might have to do it again. Also, I need to go now because.
Okay, I'll see you next time then.
Okay, until next time. Adios. Oh, don't forget to save the recording. That's an important thing.
Okay.